everyone and welcome. I'm Barbora Cernakova and I work as a full-stack developer at Theodo UK. Theodo is a full-stack development consultancy which specialises in both web and app development, and we're based in London in the UK. Today we're going to be talking about structuring your React app for reusable and consistent design, and I'm super excited to be here today. So the first question you may be asking yourself is, why this specific topic? What's the value in discussing reusability and consistency? So to give you a bit of context, towards the end of last year, I was starting on a new project within my company. And this project is for a global B2B wholesale retailer, and it's a greenfield project developing a new platform from scratch. The fact that it's a greenfield project really gave us a lot of sort of power and a lot of options at the start to actually choose the tech stack which we felt would fit the situation the best. So we as a team got together and we felt that it was really important to focus on making sure that the code base we write is easy to maintain, it's scalable, and it is easy to hand over, since as consultants, we will eventually be handing over to an internal development team within the client company. Whilst focusing on these three factors, we also wanted to make sure that we're not compromising on our speed. So after doing some initial research, we came across a couple of different tools and we decided to give them a go on this project. These two tools are Atomic Design Principle and Tailwind CSS, and I'm going to be introducing them to you in this talk today. So to give you a really quick overview of what we're going to be talking about, we're going to start by defining the terms reusability and consistency, and we'll also cover a few common problems. We will afterwards dive deep into the Atomic Design Principle, and we will also take a look at Tailwind CSS. Finally, we'll finish with a quick summary of the talk. So let's get started. So starting with the definitions and common problems. So going straight into it, reusability is defined as the use of existing assets in some form within the software development process. The keyword here is existing, which really emphasizes the fact that we are, as the term itself suggests, reusing existing components or existing bits of code elsewhere within our code base. The interesting thing about reusability for me is that there are actually varying degrees of code reuse. So, for example, if you're simply reusing 3 lines of code, which you wrote earlier today, that counts as reusability, but so does using large third-party libraries and open source frameworks. So why would we actually want to focus on ensuring that our app does subscribe to the reusability principle? One of the main advantages of reusing code is that it leads to quicker development. So I think this is actually a really intuitive statement where basically it makes sense that if we're not constantly reinventing the wheel and constantly building everything from scratch, it gives us more time to actually focus on the bits which are new, whilst we can simply reuse some of the existing factors which we already have. Another advantage is that reusing components brings a lower risk, especially when, for example, deploying to production. The reason why is that if we're building more complex components, for example, using a certain number of base components, we would expect that these base components are already used extensively across our application, hopefully have been tested extensively in both staging and are actively used in production as well. This means that we can have a lot more confidence that the components which we're building on top of are really robust, and we don't, for example, have to worry as much about missing an edge case. The third benefit which I'd like to flag is clean code. When we reuse code, the code which we write ends up being easier to understand and easier to read. This means that the code is easier to maintain and also easier to hand over. So as you can see here, we have really ticked a lot of the a lot of the aspects which within my project we were focusing early on when choosing the tools. Moving on to consistency, the Interaction Design Foundation says that consistency limits the number of ways actions and operations are represented. What this actually means is that the focus here is on users. We want to make sure that users don't have to learn new representations of each task, and so that basically they can complete new tasks without having to learn a whole new tool set. In terms of advantages, consistency leads to better development experience, where, for example, there is less confusion about which convention to follow. A really common example of this is sort of which color to pick. And also it leads to a more intuitive design, which we have already touched upon. So especially for the users, it is much simpler if we use the same flow everywhere. So in terms of common problems, I feel like reusability and consistency are factors which are sort of very widely considered to be important within the tech industry these days. But that doesn't mean that trying to implement them in real life is always going to be a smooth sailing. An example of a problem which I have definitely come across is what I would call component overload. So if you try to sort of reuse everything and extract everything into reusable components, and you have a really large code base, and let's say, for example, not many naming conventions or not much structure to your components folders, it can be really hard to find components. And this, at the end of the day, if the developer can't find the components, he or she has a much better chance of eventually giving up, even if the component already exists, and this can lead to unnecessary duplication of code. Another really common problem is variations in styling, and this actually impacts even websites of really big corporations. So what I mean here, a classic example is, for example, differences in colors. So it is really common for developers to accidentally pick the wrong RGB. So if the RGB looks similar enough so that you can't really spot the difference by naked eye, it can be really easy for sort of discrepancies like this to sneak into your code base. This again leads to both confusion for the developers and poor user experience. Poor user experience, especially if the discrepancies which sneak in are quite big and the user does spot them. Going back to the experience for developers, it can just be a lot more complicated, where, for example, the developer doesn't know which color is the correct one. So then he or she has to go on a wild goose chase to try to figure out what the correct what the correct solution is. And even, for example, let's say if your company comes to you saying, oh, we're rebranding, we want you to update our color across the whole site. This should, in theory, just be a really simple search and replace. But if you use multiple sort of color variations, which are not necessarily caught anywhere, they're sort of just accidents that have snuck in, that can again be much more painful than we'd normally expect. There are, of course, lots of other problems as well. But at this point, we're going to move on to talking about the atomic design principle. So the atomic design principle was created in June 2013, and it was first published in a blog post by Brad Frost. So it is inspired by chemistry, and specifically the fact that in chemistry, we have smaller things which join together and make up much bigger things. So Brad Frost thought about trying to abstract this into software engineering. It is really important to note that the atomic design principle is a mental model. It isn't a framework, it isn't a library which you can install within your application. It is really a method for categorizing your components and allowing you to structure them so that you can maximize efficiency and make it as friendly for the developers as possible. In terms of using the atomic design principle, there are 5 component levels. And these 5 levels are atoms, molecules, organisms, templates, and pages. So as we can see, especially at the first 3 levels, we are really sticking with that chemistry/biology theme. And by contrast, the 4th and 5th level have much more sort of like corporate standard naming. And this is very much done on purpose to bring the language at those top levels closer to something which stakeholders would be familiar with, to sort of simplify conversations. So now let's briefly talk about each one of these levels and explain what they're there for. So starting with an atom. So in the world of chemistry, an atom is the smallest particle of a chemical element. And this corresponds to exactly what we use atoms within the atomic design principle. So our atoms are our smallest and most granular components within our application. An example is a button, or for example, a text input. So both of these are really tiny components which will be used extensively throughout the whole application. Going one level higher, we run into molecules. So again, from sort of high school chemistry, we know that multiple atoms make up a molecule. And that is exactly what's happening here. So an example of a molecule would be a search component, which consists of a text field, which allows you to type in your search term, as well as a search button, which allows you to click it and trigger the search. So as you might have noticed, the two components which we use within this molecule are both atoms. So molecules are still expected to be fairly small, but going again one level higher, we arrive at organisms, which is where we're really starting to hit sort of the more complex and larger components. So again, as you'd expect, an organism can consist of either multiple molecules or even combinations of molecules and atoms. And an example of an organism would be, for example, the top bar on a website. So if we were to just imagine a website, what we could have here is our search molecule, which we have just spoken about, as well as, for example, a branding atom, which has the logo and the name of our company. And we could also have a molecule which allows us to navigate between different pages within our application. The one level higher than organisms is templates. And at this level, we are actually really hitting something tangible, which if you were to show it to a stakeholder, they would actually understand what you're showing them. So templates basically allow us to display the expected layout of various pages. But the important thing to note is that templates do not show real data. So they will only show sort of placeholder content, just really to highlight the layout. Now, finally, moving on to the final level of the atomic design principle, we arrive at pages. So pages are, as the name suggests, actual pages within our application, and they are really just instances of templates with real data. So that is really the main difference there between templates and pages. It is just whether we're showing placeholder data or actual real content. So now that we have covered the overall implementation of the atomic design principle, let's move on to discussing the advantages and disadvantages. So starting with advantages, one of the great things about the atomic design principle is that it really encourages the reuse of components. And I know I'm definitely saying this from personal experience, having worked with it for the past few months on my current project. It definitely makes you think a lot more about what you can reuse, where, for example, new components should sit, whether it's a molecule, an organism, or a template. And I think it just constantly brings the concept of reusability to the forefront of your mind when developing. I would also say that personally, I much prefer the atomic design principle to sort of the standard flat component structure. And that is primarily because I think that it is easier to use and easier to navigate, which I think is really, really important. Next, we've got scalability and consistency. So again, linking back to the fact that we are reusing lots of components. Because we're reusing them, it's a lot easier to scale since we're not constantly building everything from scratch. And also, it is great for consistency since we, again, if let's say a client went up to us and wanted us to update the hover styling on all the buttons across the application, all we'd have to do is actually just find the atom of the button and update it there, and it will propagate everywhere. So this also links me nicely onto the faster updates, where again, it's really great to note that you can, in theory, if you've done it correctly, just update one instance of your component and it will propagate everywhere. The final benefit I'd like to point out is that it also leads to easier to read code. So one thing that I've noticed, for example, is that if I'm looking at a page which uses a variety of different components, or at a file which uses a variety of different components, instead of having to click into every single component to see what it actually is, it can be much easier to get a sense of the size of it and the complexity of it just by looking at the imports. So hopefully, if your naming convention is strong enough, the combination of the name and seeing whether it's an atom, a molecule, or an organism, for example, will give you a really good sense of how big the component actually is and hopefully what it does as well. As always, there are always going to be some pain points as well. So one of the things which I personally found quite difficult to get my head around is that levels are not exclusive. So this means that you can, for example, have multiple molecules making up another molecule. And I don't think that this isn't a deal breaker with the atomic design principle. I still think that overall it's really, really good and super helpful. But I think that this was just something which definitely took me a few moments to get my head around, and it's just something that you need to be aware of when using it. Another interesting factor to note is that there is an overlap in terms of the naming with other tools. So the example which we have on our project is that, as we know, within the atomic design principle, we have pages, but also within Next.js, we also have pages. So it's, again, just something to be really aware of and slightly careful with, and especially if there's a new developer who's being onboarded onto the code base, it's these sort of things that it can be really helpful to point out. And finally, I think because it is just a mental model and it doesn't come with, like, for example, proper docs as we'd be used for a library, for example, it can be a bit confusing at first. I think that the confusion will clear after a bit of time working with the atomic design principle, and as you can all tell, I'm clearly a convert. But it's definitely worth noting that, especially at the start, there will be conversations within the team as to whether something is a molecule or an organism, and so on. So that brings us to the end of everything I wanted to mention with the atomic design principle. So we can now move on to Tailwind CSS. So Tailwind CSS was first introduced in May 2019, and it is a utility-first CSS framework. So what this actually means is that it uses low-level utility classes to build out custom and complex designs. The interesting thing about Tailwind for me is that it really does appear to be the Marmite of the CSS world. There are some developers who absolutely love it and some who absolutely hate it. And there doesn't really appear to be anyone in the middle. So the reasons why some really love it and some really hate it, I will go into in a tiny bit. I think the most important thing to note about Tailwind is that it constrains the utilities which you use within your application. So this basically means that it encourages you to build complex components from a restricted set of primitive utilities. So if you, of course, really, really wanted to upload like a custom color, you absolutely could. But also this is not something that's really encouraged within Tailwind. Now, in terms of using, this one line actually perfectly summarizes all you need to do to implement Tailwind once it's installed within your application. So all you need to do is apply pre-existing classes inline. So to show you what this actually means, we have a really short code snippet here where we've got one div with a child component. And on the top level div, we've got a class name and a really long string. So I think when you first look at this can look quite intimidating. But if we talk through it, you'll see that there's nothing scary about this at all. So in the class name, the first term we've got is flex, which basically just tells Tailwind that we want this div to be a flex box. The next term is items end, which means that we want to align items to the end of the container's cross-axes. Justify center means that we want to align items to the center of the container's main axes. Min H screen stands for minimum height screen. So we're basically saying that we want the minimum height of the div to be set to the height of the screen. Now next we hit the padding terms. So we've got PT, PX, and PB. PT stands for padding top, PX for padding x-axis, so padding left and padding right, and PB for padding bottom. As you can see on all of this, we've got the number appended at the end, which basically indicates how big we want our padding to be. And finally, we've got text center, which just indicates that we want our text to be aligned to the center. So I know that this can seem like a lot, but what's really good to note is that the Tailwind docs are really good and they're really clear. So if you feel like this is a lot and there's a lot of sort of language and terms to get used to, honestly, the Tailwind docs will have you covered. So as you can see, the advantage here is that we've basically just summarized all the styling into this one long string. So to give you an example of what it would look like using sort of the standard external CSS to the component. So I know that this screenshot is really, really tiny, but this is code taken from the Tailwind website. It's good to note that in here, we actually have code written in HTML. And that's why we use class instead of class name, but the principle is absolutely the same. So at the top 6 or so lines, we basically create a div, which has a heading and a paragraph within it. And then the remaining 2/3 of the screenshot we are just specifying the styles which we want to apply to those first 6 lines. Now, by comparison, this is what it shows like implementing Tailwind. So as you can see, we have cut down literally about 2/3 of the lines from the previous screenshot. And we now just specify the styling all in line. And especially because, as we said, sort of Tailwind provides a restricted set of class names. That means that we can use sort of shorthand to specify exactly what we want the styling to do. Now, moving on to advantages, one of my favorite things about Tailwind is that it can handle hover and focus states in line. Whilst this is not something which normal CSS can do, but in Tailwind, all you need to do is within your long string, just specify hover, colon, and the styling you want to apply, and Tailwind will deal with that for you. Tailwind also provides headless UI, which is a library of completely unstyled and fully accessible UI components, which are intentionally designed to work really well with Tailwind. So an example here is you could get a modal, a popover, or a radio group, and it again sort of simplifies your development process that one step further, since you don't have to go back to the scratch to create all of this. Another really strong advantage of Tailwind is speed. So Tailwind works by scanning all of your files, looking for class names. It then generates the corresponding styles and finally writes them to a static CSS file. This means that your CSS bundle in production is tiny. It is way smaller than any other sort of CSS tools which you could potentially be using, and this really speeds up your application. It also encourages consistent design and component-first design, which again sort of takes us back to that reusability and making sure that we are building our application in a way which is as maintainable and as easy to hand over as possible. So especially with the component-first design, you will be really encouraged to do this because, as you've seen, we've got the Tailwind normally consists of the long strings, So by component first design, you will be sort of trying to make those strings a bit shorter and a bit more manageable. And finally, as I've already mentioned, their docs are absolutely amazing. Now, on the other hand, one of the main disadvantages is that I feel like there is a fairly steep learning curve with Tailwind, especially if you've not really used much CSS before. I think that for complete beginners, it might be nice to get started with something like styled components, which is still a really powerful tool, but it allows you to use CSS in a much more traditional way. This is just a personal opinion, but I honestly still think that it looks ugly. I'm not a huge fan of having massive strings of class names within my components, but I think this disadvantage absolutely does not outweigh all the benefits that Tailwind brings to me. And there are also other things which you can do here. So for example, if you really wanted to, you could extract this code to module.css files. Finally, it's also worth mentioning separation of concerns. So separation of concerns is a design principle for separating a computer program into distinct sections. So traditionally, this would mean, for example, keeping your JavaScript files separate to your CSS files. So realistically, it's really up for debate whether this is even used nowadays within React and whether it is a relevant disadvantage. But as we said previously, you can, for example, there are some workarounds to this where you can, for example, extract your Tailwind strings into module.css files. So that concludes everything I was going to tell you about Tailwind CSS. So finally, moving on to the summary. So the main key takeaway I would like you to take away from this is that if you implement reusability and consistency within your application well, it will speed you up in the long term. I think especially if you've got an existing code base, which might struggle with some of the issues which I mentioned earlier, it can feel like a lot of effort, and it can even be difficult to persuade stakeholders that it is worth making these changes. But honestly, in the long run, it will make a massive difference, and even small changes will add up pretty quickly, and you will be able to feel a difference. So I think, as you can tell, I have really, really loved using both the Atomic Design Principle and Tailwind CSS on my project. But it's really important to flag that whilst they've both worked perfectly in my use case, they may not be well suited for your use case. So I would say, whilst this has, I hope, been a good introduction to both of these tools, but I would definitely say go ahead and do more research before jumping headfirst into anything. But fingers crossed, this has at least inspired you to take a look into using these tools. And finally, if you are looking to get started, the docs are absolutely the best place to do this. As I've mentioned a few times already, the Tailwind docs are really, really good, and they provide really clear steps to both allow you to get set up really quickly, as well as to actually search for the various class names, which is probably where the biggest sort of learning curve actually is. And going back to the Atomic Design Principle, I would absolutely recommend going back to Brad Frost's original blog post. And since then, he has also written more materials on it. So potentially even looking further into the Atomic Design Principle. Thank you so much for attending the talk today. I hope you've enjoyed it, and have a great day.